Hello, everyone. Today we're going to go over the homework for sections 5.2 and 5.3. We start the 5.2 homework with exercises 1 through 4, where we're performing the indicated unit conversions with the direction to round to the nearest hundredth, if necessary. In number 1, we are converting 4.2 feet to inches. We have 4.2 feet and we need to cancel feet out. That means feet needs to be on the bottom of our unit conversion. And since we want inches, inches has to be on top. Then with our calculator, we multiply 4.2 times 12 to get 50.4. Feet cancel and we're left with inches, 50.4 inches. In number 2, we're converting 4.2 feet to yards. Once again, we're starting with 4.2 feet. We need feet to be on the bottom of our conversion and yards to be on the top. 1 yard is 3 feet, so we have 1 yard over 3 feet. This time we're dividing 4.2 divided by 3, and we get 1.4. Feet cancel and we're left with yards, 1.4 yards. In number 3, we're starting with 76 inches and we want to convert to feet. Since we're starting with inches, we need to cancel inches out. Inches needs to be on the bottom of our conversion factor. Since we want feet, feet has to be on the top of our conversion factor. 1 foot over 12 inches would be our conversion factor. Inches cancel on the top and on the bottom. We would have 76 divided by 12, or if you want, 76 times 1 divided by 12. Either way, you're going to get about 6.33. Inches canceled, leaving us with feet, 6.33 feet. And number 4, we want to convert 12,000 feet to miles. We're starting with 12,000 feet. Our conversion factor has to have feet on the bottom in order for that to cancel. We're going to use miles on top since we want to convert to miles. And the conversion factor with miles and feet is 1 mile over 5,280 feet. So in the calculator, 12,000 times 1 divided by 5,280 gives us 2.27. Feet canceled, leaving us with miles, so 2.27 miles. The book actually has 2.273 miles, breaking its own rule of rounding to the nearest hundredth. So that one is not rounded correctly. Correctly, we should have 2.27. Number 5, we're going to convert 0.85 miles to feet. We're starting off with 0.85 miles. Miles then needs to be on the bottom in order to cancel away. We need feet on top since we want our answer in feet. The conversion factor with feet on the top and miles on the bottom is 5,280 feet over 1 mile. Miles cancels, leaving us with feet. 0.85 times 5,280 divided by 1 calculates to 4,488 feet. In number 6, we're converting 0.85 miles to yards this time. Now, we're going to cheat a little bit, and we're going to start with the 4,488 feet that we got in the previous problem. Otherwise, we would need to convert miles to feet again first. Starting with that 4,488 feet, knowing that we want feet to cancel, feet has to be on the bottom of our conversion factor. Yards has to be on top since that's what we want. Feet cancel, leaving us with yards. We calculate 4,488 times 1 divided by 3, and we get 1,496 yards. In number 7, we're converting 6 feet 7 inches into all inches. So first we need to convert the 6 foot. 6 feet is what we start with. To cancel out feet, we need feet on the bottom. We need it to be in inches, so our conversion factor has inches on the top, and that conversion factor would be 12 inches over 1 foot. Feet cancel, leaving us with inches. 6 times 12 divided by 1 is 72. So the 6 feet part is 72 inches. Adding the other 7 inches to that, we get 79 inches, 72 plus 7. Number 8, we're going to convert 3 feet 9 inches to decimal feet. So first, let's convert the 9 inches to feet. We're starting with 9 inches. To cancel inches away, we'll need inches on the bottom. And since we want it into feet, that's going to be feet on top. The conversion factor with feet on top and inches on the bottom is 1 foot over 12 inches. 9 times 1 divided by 12 gives us 0.75 feet. Add that to the 3 feet from the original problem. 3 feet plus 0.75 feet gives us 3.75 feet. Next, 175 inches to feet and inches. We're going to start with our conversion factor of feet to inches. We need inches on the bottom to cancel out the inches we're starting with, and we need feet on the top to convert to feet. Inches cancels, leaving us with feet. 175 times 1 divided by 12 gives us 14.5833 feet. We need feet and inches, though, so we need to find the remainder. 14 feet times 12 inches per foot gives us 168 inches. We started with 175 inches. If we subtract the 168 inches, that is 14 feet. That leaves us with 7 inches left over. So 14 feet, 7 inches. Next, we're going to convert 67 inches to feet and inches. We're going to follow the same process. First, to cancel away inches, we need inches on the bottom. To get it in feet, we need feet on top. 1 foot over 12 inches cancels inches away, leaves us with feet. 67 times 1 divided by 12 gives us 5.5833 and so on feet. We're only interested in the 5-foot part of that. We need to convert the rest to a remainder. So 5 feet is how many inches? 5 feet times 12 inches per foot cancels feet away and leaves us with inches. 5 times 12 divided by 1 is 60. So the 5 feet is 60 inches. We started with 67 inches. 67 inches minus 60 inches leaves us with 7 inches left over. So 5 feet, 7 inches. In number 11, we are to calculate the perimeter or circumference of the given figure. We have a triangle, not a circle, so that's going to be perimeter. And to find the perimeter, we add the sides. If we start down here on the bottom left of the figure and move counterclockwise, 7 plus 4 plus 6 gives us 17 inches as the perimeter. Same in number 12, calculate the perimeter or the circumference. And since we have a circle, we'll be calculating the circumference, the distance around the circle. We're going to use circumference equals pi times diameter, or circumference equals 2 times pi times radius. Either way, we need to multiply our radius by 2. 2 times 1.3 gives us a diameter of 2.6 times pi. We're using 3.14159 for pi. 3.14159 times 2.6 gives us 8.168134 feet. Rounded to the nearest hundredth, that is 8.17 feet. Number 13, we're calculating the perimeter, but our sides are given in different units. We have 1.5 feet and we have 8 inches. We can't just add 1.5 plus 8 plus 1.5 plus 8 because the units aren't the same. Since 8 inches isn't even a full foot, let's convert feet to inches first. 1.5 feet times 12 inches per foot will cancel feet away, leave us with inches. 1.5 times 12 divided by 1 gives us 18 inches. So now let's add the sides. 18 inches plus 8 inches plus 18 inches plus 8 inches gives us a perimeter of 52 inches. Number 14, we're doing perimeter again. Let's go ahead and add the sides. Let's start in the bottom left. Everything is in centimeters, so we don't have to do any conversions first. We just need to remember to stop where we started. So from the bottom left, going counterclockwise. 20 plus 12 plus 8 plus 8 plus 4 plus 8 plus 8 plus 12. Then we stop because that's where we started. Adding those numbers together gives us 80 centimeters as the perimeter. Number 15, calculate the perimeter or the circumference of the given figure. This one is kind of mixed. We want the distance around this half circle. That would be this left side plus half of the circumference of the circle. So let's find the full circumference of the circle first. The circumference would be pi times the diameter. And this 16 inches is a diameter. So 3.14159 times 16 gives us 50.26544. Half of that, since we're only going halfway around a circle, would be 25.13272 inches. Add 16 to that to finish off the perimeter. 16 plus 25.13272 is 41.13272, and we can round that off to 41.1 inches. Number 16, we want to calculate the length of the unknown side of the triangle. For that, we're going to use the Pythagorean theorem. We want to find the hypotenuse. We want to find C. So we use the Pythagorean theorem. A squared plus B squared equals C squared, where A and B are the lengths of the legs. So 12 inches squared plus 5 inches squared equals x squared. When we square 12 inches, we get 144 square inches. When we square 5 inches, we get 25 square inches. And when we square x, we get x squared. Add together the left side. 144 square inches plus 25 square inches is 169 square inches. To get the x by itself, we take square roots of both sides. The square root of x squared is just x. The square root of 169 square inches is 13 inches. So the unknown side, x, is 13 inches. Number 17, we're going to do it again. Calculate the length of the unknown side of the triangle. We're looking for the hypotenuse again, so we're looking for C again. The legs are 7 feet and 5 feet. So 7 feet squared plus 5 feet squared equals x squared. When we square 7 feet, we get 49 square feet. When we square 5 feet, we get 25 square feet. And when we square x, we get x squared. Add together the left-hand side. 49 square feet plus 25 square feet is 74 square feet. So we have 74 square feet equals x squared. To get the x by itself, take the square root of both sides. The square root of x squared is x. The square root of 74 square feet is about 8.6 feet. So the unknown side is about 8.6 feet. Number 18. We again want to calculate the length of the unknown side of the triangle, but one of the legs is given in inches. The other leg is given in feet. Since 18 inches would be a decimal number of feet, let's convert feet to inches so that everything is a nice integer. Converting 2 feet to inches, we would need inches over feet, and that would be 12 inches over 1 foot. That cancels feet away from the top and bottom. It leaves inches on top like we need. So 2 times 12 divided by 1 is 24, 24 inches. We put that in as our first leg, squaring 24 inches, plus our other leg, squaring 18 inches, equals our unknown squared, x squared. When we square 24 inches, we get 576 square inches. When we square 18 inches, we get 324 square inches. Adding together the left-hand side, 576 square inches plus 324 square inches is 900 square inches. That equals x squared. To get the x by itself, we take the square root of both sides. The square root of x squared is x. The square root of 900 square inches is 30 inches. So our unknown side is 30 inches. Number 19. Once again, we're calculating the length of the unknown side of the triangle, but this time our unknown is not the hypotenuse, it's one of the legs. Everything's given in feet, so we don't have to do any conversions. Let's plug in 1.8 feet as one of our legs. Let's plug in 3 feet as the hypotenuse. So 1.8 feet squared plus x squared equals 3 feet squared. When we square 1.8 feet, we get 3.24 square feet. And when we square 3 feet, we get 9 square feet. When we square x, we get x squared. Now we don't have things to add together on the left, but we do need to get the x squared by itself. In order to do that, we subtract 3.24 square feet from both sides. 9 square feet minus 3.24 square feet is 5.76 square feet. To get the x by itself, we take square roots of both sides. The square root of x squared is x. The square root of 5.76 square feet is 2.4 feet. So our unknown leg is 2.4 feet. We're going to do it again with number 20. Our unknown is a leg, but we know one of the legs is 6 inches. So plug in 6 inches for A, plug in X for B, and plug in our hypotenuse 8 for C. We have 6 inches squared plus X squared equals 8 inches squared. When we square 6 inches, we get 36 square inches. When we square x, we get x squared. And when we square 8 inches, we get 64 square inches. We need to get x squared by itself first, so subtract 36 square inches from both sides. 64 square inches minus 36 square inches is 28 square inches. To get the x by itself, we need to take square roots of both sides. The square root of x squared is x. The square root of 28 square inches is about 5.29 inches. So our unknown leg is about 5.29 inches. Number 21. Daisy is building a window box for growing flowers in her apartment. Is one 7.5-foot board enough material to build the walls of this flower box? Well, one of our sides is given in feet. The other is given in inches. Since we need to compare our answer for perimeter to a 7.5-foot board, we need to convert to feet. So it might be easier mathematically to convert the 3 feet to inches, but since we need to compare to feet in the end, we need everything to be in feet. So first, let's convert inches to feet to match the problem. We need inches on the bottom to cancel inches away. We need feet on the top. Our conversion factor with feet on top and inches on bottom is 1 foot over 12 inches. That cancels away inches and leaves us in feet. 8 times 1 divided by 12 is 0.67 feet. That means when we look at the perimeter, we have 3 feet plus 0.67 feet plus 3 feet plus 0.67 feet. And that gives us 7.34 feet, which means yes, 7.5 feet is enough board to build the walls of the flower box. In number 22, John is putting a fence around his property, but needs to build around his garage, as depicted in the figure below. How much fencing will he need to purchase? So he's going around his property, but skipping the garage. The garage is on the outside of the fence. How much fencing he'll need to purchase? That's just going to be the perimeter. So let's start in the bottom left of the figure, go counterclockwise like we always do, and add up all the sides. 44 plus 40 plus 56 plus 24 plus 12 plus 16 gets us back where we started, and those numbers add up to 192 feet. In number 23, Janice is building a frame for an art print. If the print is on a canvas measuring 7 foot 3 inches by 5 foot 9 inches, how much material will she need for the frame? So let's add the feet first. Starting in the bottom left, just looking at the feet, we have 7 feet plus 5 feet plus 7 feet plus 5 feet. Next, let's add the inches. 3 inches plus 9 inches plus 3 inches plus 9 inches. That's 24 inches, and when we convert 24 inches to feet, 24 inches times 1 foot over 12 inches is 24 times 1 divided by 12. That gives us 2 feet. Combining 24 feet plus 2 feet gives us 26 feet of material needed for the frame. Number 24. As part of a set design, the company needs to form a circular metal hoop that will stand up 5 feet tall. If they want to bend the hoop from a single aluminum rod, how long does the rod need to be? So we need to know the circumference of a circle with a diameter of 5 feet. Once this circle is standing up, top to bottom, it would be 5 feet. Top to bottom would be a diameter. Since it's a circle, we want circumference. Circumference equals pi times diameter. So we go 3.14159 times 5, which gives us 15.70795, which rounds to about 15.71 feet. We would need 15.71 feet to bend into a circle to give us a diameter of 5 feet. Number 25. If you form a wreath by bending an 8-foot-long branch into a circle such that the branch goes around twice, how wide will the wreath be? Talking about how wide a circle is, how long it is, that's a diameter. So we're looking for the diameter. If the branch goes around twice and it's an 8-foot-long branch, that means it's going around 4 feet each time. So 0 going around once is 4 feet, going around twice makes 8 feet. So we want to know how wide the wreath will be if it has a circumference of 4 feet. So circumference equals pi times diameter. The circumference is 4. Pi is 3.14159. We don't know the diameter. To get the diameter by itself, we need to divide both sides by pi. So 4 divided by 3.14159 is approximately 1.27 feet for the diameter. 8-foot-long branch going around in a circle twice ends up 1.27 feet wide. Number 26. Jim and Tim are pulling guy wires to raise a 10-foot flagpole. If the guy wires are each 16 feet long, how far will Tim be from the base of the flagpole once it is upright? This forms a right triangle with one leg 10 feet and a hypotenuse of 16 feet. We want to know how far away from the base of the flagpole Tim will be. We are looking for another leg, the horizontal leg. So we use our Pythagorean theorem, a squared plus b squared equals c squared. Plug in the one leg we know, 10 feet. Our other leg is an unknown, x. The hypotenuse is 16 feet. When we square 10 feet, we get 100 square feet. When we square x, we get x squared. When we square 16 feet, we get 256 square feet. To get the x squared by itself, we need to subtract 100 square feet from both sides. 256 square feet minus 100 square feet is 156 square feet. So x squared equals 156 square feet. We want to take the square root of both sides to get x by itself. And the square root of 156 square feet is about 12.49 feet. So Tim is about 12.49 feet away from the base of the flagpole. And lastly, in the 5.2 homework, we have number 27. The sign at Don's doorstop shop is in the shape of a right triangle, 2 feet tall and 5 feet wide. If Don wants to wrap tinsel around the sign to make it festive, how much tinsel will he use? When we're wrapping something around something, that tells us perimeter. We only know that it's 2 feet tall and 5 feet wide, though. It's a right triangle and we're missing the length of the hypotenuse. So we need to find the length of the hypotenuse first before we can calculate the perimeter. So plugging into the plugging into the Pythagorean theorem, we have our legs of 2 feet and 5 feet. The hypotenuse is unknown. The hypotenuse is x. So 2 feet squared plus 5 feet squared equals x squared. When we square 2 feet, we get 4 square feet. When we square 5 feet, we get 25 square feet. And when we square x, we get x squared. Add together the left-hand side. 4 square feet plus 25 square feet is 29 square feet. So 29 square feet equals x squared. Take the square root of both sides. And the square root of 29 square feet is 5.39 feet, thereabouts. So the perimeter, the distance around, is 2 plus 5 plus 5.39, or 12.39 feet. He would need 12.39 feet of tinsel to make it all the way around the right triangle-shaped sign. Moving into the 5.3 homework. In number 1, we want to solve the given proportion. We're given 2/3 equals 9 over x. We want to use cross products. So 2 times x equals 9 times 3. That means 2x equals 27. To get x by itself, divide both sides by 2. X equals 27 halves, which is 13.5. X equals 13.5. In number 2, we're going to solve this proportion. 3 over x equals 12 over 25. Again, we want to do cross products. So 12 times x equals 3 times 25. That gives us 12x equals 75. Dividing both sides by 12 gives us 75 divided by 12, or 6.25. So x equals 6.25. We're getting trickier. We have decimals all over our proportion in number 3. 3.5 over x equals 12.7 over 36.2. Cross products, x times 12.7 or 12.7x equals 3.5 times 36.2. That means 12.7x is 126.7. Divide both sides by 12.7, and 126.7 divided by 12.7 gives us approximately 9.98 for x. Number 4, now we have mixed numbers inside of our proportion. We have to change our mixed numbers into improper fractions first. So 3.5, 2 times 3 is 6, plus 1 is 7. 3.5 is 7 halves. On the bottom, 5 1/3. 3 times 5 is 15, plus 1 is 16 thirds for the bottom. So 7 halves times x equals 16 thirds times 7. Seven halves times x is just 7 halves x. 16 thirds times 7 is 112 thirds. Divide both sides by 7 halves. Dividing by a fraction is multiplying by the reciprocal. So multiply both sides by 2/7. 2/7 times 7 halves times x just leaves us with x. 112 thirds times 2/7 is 224 over 21. Let's turn that back into a mixed number because we had mixed numbers in the problem. 224 divided by 21 is 10 14/21. 10 with a remainder of 14, which goes over the 21. And 14/21 reduces to 2/3. So 10 2/3 is our x. Number 5, use the given unit rate to find the indicated measurement. Number 5 says gasoline is priced at the unit rate of $2.579 per gallon. How much will 9.4 gallons of gasoline cost? So we're starting with 9.4 gallons. We want to convert to dollars. To cancel the gallons away and leave us with dollars, we need gallons on the bottom and dollars on top. So 9.4 gallons is going to be multiplied by $2.579 over 1 gallon. Gallons cancels, leaves us with dollars. 9.4 times 2.579 divided by 1 gives us $24.24. Number 6. If Sam needs to drive 148 miles at the posted speed limit of 55 miles per hour, how long will the trip take? We're going to convert from miles to hours, and we're starting with 148 miles. To cancel miles, miles needs to be on the bottom. To get it into hours, hours needs to be on top. So we multiply by 1 hour over 55 miles. Miles cancels, leaving us with hours. 148 times 1 divided by 55 gives us approximately 2.7 hours. Number 7. A typical garden hose will deliver 17 gallons per minute of water. How long will it take this hose to fill a 639-gallon pop-up swimming pool? So we want to convert from gallons to minutes. The question asks how long. The unit of time that we were given is minutes. So we start with our 639 gallons. In order to cancel gallons, gallons needs to be on the bottom. In order to leave us with minutes, minutes needs to be on top. So we're multiplying by 1 minute over 17 gallons. Gallons cancels, leaving us with minutes. 639 times 1 divided by 17 gives us approximately 37.6 minutes. Number 8. One type of cherry wood crown molding costs $6.72 per foot. How much will it cost to purchase enough of this crown molding to install around a rectangular room that measures 8 feet by 12 feet? So we know the room measures 8 feet by 12 feet. We need to find the perimeter. 8 plus 12 plus 8 plus 12 gives us 40 feet that we need to cover. And we need to convert that 40 feet into dollars. We need feet on the bottom in order for feet to cancel. We need dollars on top in order to leave us with dollars. So we multiply by $6.72 over 1 foot. Feet cancel, leaving us with dollars. 40 times 6.72 divided by 1 gives us $268.80. Numbers 9 through 11 are skipped because these require knowledge of the skipped section 5.1. So moving on to number 12. Use properties of similar triangles to determine the length of the unknown side. We have 3 inches, which is going to correspond to 4.5 inches in the other triangle. Our unknown is going to correspond to the 5-inch side. So 3 is to 4.5 as 5 is to unknown. That's the proportion that we set up. Cross multiplying, 3 times x equals 4.5 times 5. 3x then equals 22.5. And dividing both sides by 3 gives us 7.5 inches as our unknown side. You could have also set up the proportion as 5 over 3 is x over 4.5, or 3 over 5 is 4.5 over x. As long as your corresponding things are across from each other or over each other, you are good. You'll get the same answer. The number we didn't have to use here was the 7 inches. We weren't asked anything about this side XZ. We were specifically asked about YZ. Number 13. In this figure, the L corresponds to G, which means the M corresponds to H, and the N corresponds to F. So we kind of have to flip this over and then up to see it in the same position. The 2 inches corresponds to the 15 feet. Our unknown corresponds to the 6. So small triangle has a 2, big triangle has a 15, 2 over 15. Small triangle has a 6, big triangle has an unknown, 6 over x. Cross multiplying, 2 times x equals 6 times 15. 2x equals 90. Dividing both sides by 2, x equals 45 and that triangle is in feet. So 45 feet. Number 14. We have similar triangles. We're looking for the hypotenuse of the big triangle. That corresponds to the hypotenuse of this small triangle. This side of the big triangle is 10 feet. The corresponding side of the small triangle is 3 feet. So if we go big triangle on the top, small triangle on the bottom, one of our ratios is 10/3. Keeping big on top, small on the bottom, x, our unknown, over 5. So we have 10/3 equals x over 5 as one of the possible proportions you could have made. But there are other possibilities that lead to the same answer. You could have, for instance, done 10/x equals 3/5, and you'll get the same answer. As long as corresponding parts are in corresponding places. But if you have 10/3 equals x over 5, cross multiplying gives us 3 times x over 10 times 5, or equals 10 times 5, excuse me. That means 3x equals 50. Divide both sides by 3. 50 divided by 3 is approximately 16.7, and everything here is in feet. So 16.7 feet. Number 15. Again, we have similar triangles. This time it's a nested triangle. We're looking for this piece right here, segment ST. We're going to call that X. This piece of the smaller triangle corresponds to this piece of the larger triangle. So one of our ratios is 3.6 over 4.9. Keeping the smaller triangle on top, this piece of the smaller triangle is 5.2. The corresponding piece of the larger triangle would be 5.2 plus x. So 5.2 on the top, 5.2 times x on the bottom. Cross multiplying, we would have 3.6 times 5.2 plus x equals 5.2 times 4.9. Distribute the 3.6. 3.6 times 5.2 is 18.72. 3.6 times x is 3.6x. And then 4.9 times 5.2 is 25.48. To start getting x by itself, we need to get 3.6x by itself. Subtract 18.72 from both sides. And 25.48 minus 18.72 is 6.76. So we have 3.6x equals 6.76. Divide both sides by 3.6. We get 6.76 divided by 3.6, which is approximately 1.88. Everything here is in feet. So approximately 1.88 feet is this piece, segment ST. Number 16. The Americans with Disabilities Act requires that commercial buildings have ramp access with a height to length ratio of at most 1 to 12. How long would a ramp need to be in order to access a door 7 inches above the sidewalk? 7 inches is the height of the ramp. We are looking for the length. 1 to 12, it says, is a height to length ratio. So we want height on top. We want length on the bottom. 1 over 12 equals 7 height over x length. Cross multiplying, 1 times x equals 7 times 12. X then is 84 inches. The length would have to be 84 inches. Number 17. An ant is crawling along the disc of a power sander when it suddenly starts spinning at 4,500 revolutions per minute. Poor ant. Assuming that the ant somehow manages to hold on, how many times will the ant be spun in a circle in the 0.625 minutes the power sander is running? So we want to convert the 0.625 minutes to revolutions. In order to cancel minutes, we need minutes on the bottom. There should be a parenthesis there after 1 minute. So minutes on the bottom to cancel minutes, revolutions on top, because that's how many times it will be spun in a circle. And that's what we're looking for. So we want the number of revolutions. Our conversion factor then is 4,500 revolutions on top, 1 minute on the bottom. Minutes cancel, leaving us with revolutions. 0.625 times 4,500 divided by 1 gives us 2,812.5 revolutions. Number 18. Sam makes a 132-mile commute along one highway every day, and he drives exactly the speed limit. They just lowered the speed limit on that stretch from 55 miles per hour to 40 miles per hour. How much longer will Sam's commute now take? We need to convert 132 miles to hours both ways, then find the difference. So first, at 55 miles per hour, we would need miles on the bottom and hours on top to cancel out miles and leave us with hours. So our conversion factor is 1 hour over 55 miles. Miles cancels, leaving us with hours. 132 times 1 divided by 55 gives us 2.4 hours at 55 miles per hour. Now we do it again at 40 miles per hour. In order to cancel miles, miles needs to be on the bottom. And in order to give us hours, hours needs to be on top. So 1 hour over 40 miles is our conversion factor. 132 times 1 divided by 40 gives us 3.3 hours. So how much longer is it going to take? We subtract 3.3 minus 2.4 and get 0.9 hours. So it's going to be 0.9 hours longer at 40 miles per hour. Number 19. On one town map, 2 centimeters represents 5 kilometers in the real world. At this rate, how long is the river walk, which is represented by a line measuring 4.6 centimeters on the map? So 2 centimeters represents 5 kilometers. Centimeters on top, kilometers on the bottom. One of our ratios then is 2/5. At this rate, how long is the river walk, which is represented by a line measuring 4.6 centimeters? Keep centimeters on the top, 4.6. It is an unknown number of kilometers on the bottom. So 2/5 equals 4.6/x. Cross multiply, get those cross products. 2 times x equals 5 times 4.6. 2x then equals 23. Divide both sides by 2, and 23 divided by 2 gives us 11.5. The bottom numbers are kilometers, so 11.5 kilometers. Number 20. A 12 centimeter wide disc is held between a flashlight and a wall, as shown in this picture. Find the length of the shadow on the wall if the disc is 40 centimeters from the wall and 15 centimeters from the flashlight. So step 1 is draw a picture. Doesn't have to be as detailed as this one, but it should have the relevant pieces of information. Here's our flashlight. There's the wall. There's a shadow on the wall. The disc is 12 centimeters wide, which is the same as 12 centimeters tall. It's 15 centimeters from the flashlight. It's 40 centimeters from the wall. This sets up a proportion of nested triangles. They are similar triangles. One of their heights, the big triangle made from the flashlight to the wall, has a height of 15 plus 40 centimeters. The smaller triangle, made up of the flashlight to the disc, has a height of 15 centimeters. So one of our proportions, small triangle to big triangle, is 15 to 15 plus 40, or 15 to 55. Since we want to find the length of the shadow, the corresponding piece of the little triangle is 12 centimeters. And the other corresponding side is the shadow that we're looking for. So the other ratio, little triangle to big triangle, is 12 to shadow. Instead of using x, I'm going to leave it as shadow. So 12 over shadow is equal to 15/55. Cross multiplying, we have 15 times shadow equals 12 times 55. 15 times shadow then would equal 660. Dividing both sides by 15, the shadow is 660 divided by 15, or 44 centimeters. Because everything here was in centimeters. And finally, number 21. Aaron is launching model rockets. And Aaron is safely sitting on the ground 50 feet away watching. This is a problem about Aaron and Aaron. From Aaron's point of view, The last rocket appeared to peak at about the same height as a flagpole that happened to be between him and the launch site. If the flagpole is 10 feet tall and 8 feet away from Aaron, how high did the last rocket actually get? The first step is to draw a picture which models the situation. So here's Aaron over here, sitting on the ground, 50 feet away from the rocket. In between the rocket and Aaron is a flagpole that's 10 feet tall, and that flagpole is 8 feet away from Aaron. We want to know how high the rocket got. So one triangle is made up of Aaron to the top of the flagpole, to the bottom of the flagpole, back to Aaron. The larger triangle that this is nested inside is Aaron to the top of the rocket, to the ground where the rocket lifted off, back to Aaron. Let's solve a proportion. This side of the little triangle is 8 feet. This side of the big triangle is 50 feet. This image is not to scale, and that is okay, as long as everything's in the right spot. So little triangle to big triangle gives us 8 to 50 as one ratio. Over here, little triangle is 10, big triangle is x. So the other is 10 over x. Cross multiplying, 8 times x equals 50 times 10. 8 times x then equals 500. Dividing both sides by 8, 500 divided by 8 is 62.5 feet, because everything here is in feet. So that's the end of the 5.3 homework. Next time I see you, we're going to go over section 5.4.